Let's see how to get the transpose of a matrix. Um, Let A be a two-dimensional matrix which we get by using the A range and the reshape. So basically this is A. So if I want to take a transpose, I can use the T function or the T property. So this would give a transpose of A, or I can use the transpose method. If I don't pass anything to the transpose method, it would uh, give a regular transpose. But I can, if I have higher dimensional arrays and I want the order, the axes stacked in a particular order, I can do that. So here if I say 0 comma 1, so this would essentially return A as it is, with the 0th axis as the 0th axis and the first axis as the first axis. So this is A as it was, but instead if I say 1 comma 0, this would be so this what this means is that axis 0 would now mean axis 1, and axis 1 would now mean axis 0. So this is another way of getting the transpose. If you have higher dimensional arrays, you can pass the order in which you want the axes to be lined, and you can obtain that using this method. So this is how you get the transpose of an array. Let's talk about a set of general purpose functions called the ufuncs, or the universal functions. These include functions like sine, cos, tan, square root, which work on just one array, or functions like uh, sum or add, subtract, minimum, maximum, which work on two arrays. So let's say I had an array A. So this was my array A, 0, 1, 2, 3, and this was B. So this is 4, 3, 2, 1. So I can use the maximum function. So I can use np dot maximum A comma B. So this would essentially perform an element-wise maximization. So the output would be the maximum uh, of the elements, like on an element level. So you get 4, 3, 2, 3. This is because the maximum of 0 and 4 is 4, 1 and 3 is 3, 2 and 2 is 2, and 3 and 1 is 3. So this is an element wise maximization. We can also take a look at all the functions available at the documentation. So the link to the documentation would be provided in the resources file. Um, the list of universal functions available can be again categorized as math operations like add, subtract, multiply, divide, or the log operations, or the exponential operations. So there's a long list of math operations which you can do. Then there are trigonometric functions like sine, cos, tan, etc. There are bitwise operations. There are comparison functions. There are also floating functions which perform different kind of stuff. So you might want to check out this documentation and see all the general purpose universal functions you can use. You might have to come across some of these in the code, which would be which you would see in the rest of the course. So go ahead and check this documentation out. Again, it is link to this is provided in the resources file. um, so this is about the universal functions. Let's take a look at the some methods for computing the statistics of arrays. These statistics could be like sum or mean or variance or covariance between two arrays. So let's get started with that. So this is the array we have. So it is a 4 by 4 matrix. So I can use the sum method to compute the sum of all elements. So if you add all numbers from 0 to 15, the answer is 120. So the sum method has computed the sum of all elements. This is the behavior of the sum method or any such method if you do not pass the access parameter or any parameter to the method. So, but you can also pass the access parameter to the method. If you do so, the operation would be done along that axis. So if you pass 0, so it would, the sum operation would be done along the row axis. So you would get one value per column. So this is addition along the row axis, producing a value each for each column. So I can also pass the value 1, which would perform the operation on the column axis, producing one value per row. So these are some of the ways you can use the statistics functions. Now we can take a look at the various statistics functions present. So these are a list of these can be found in the documentation. So these include order statistics like argmax or argmin, or averages and variances, or correlations, or histograms and stuff like that. So basically a list of all these methods can be found in this documentation page. A link to this documentation page would be available in the resources file again. So make sure you take a look at the statistics which you can perform for the arrays, and because these are really important and powerful, computing sum, mean, and average. These are stuff which you would be doing quite often. So make sure that you take a look at these. Let's get started with the linear algebra functions which are provided by the Numpy package. The people who have taken the any kind of linear algebra course would be familiar with these functions. These functions are popularly used in when data is represented as matrix or vectors. So let's take a quick look at those functions. Let's start by creating an array. So this is our array. Let's try inverting this array. So all the linear algebra methods are are present in the linalg library. So you would say np.linalg if you want to use any of the linear algebra methods, or you could import these methods explicitly. So let's try inverting the matrix. So this is how you would invert this matrix 0, 1, 2, 3. So this is the inversion of that matrix. The list of the linear algebra functions can be found at on their documentation page. So the link to the documentation page would be provided again in the resources file. So go do take a look at that. So the various linear algebra functions would be matrix and vector products. So these would be dot product, or the inner product or outer product. Decompositions, including the Cholesky decomposition or a singular value decomposition, or computing eigenvalues, computing the norms, solving equation or inverting matrices. Inverting matrices, one kind of that has been, we just looked at it. So do take a look at this documentation. Let's take a quick look at the random package in Numpy. This allows you to create random numbers as simple data, or you could also use different distributions to generate a random numbers. Let's start by creating an array of random numbers. As I said, the random functions are in the random package. So you should use np.random to specify the package name. And let's use the rand function. The rand function basically would take in the size of the required array as input. So let me say a 2 by 2 matrix, and create a matrix of the given size uh, from 0 to 1. So the values would be from 0 to 1, and it would follow the uniform distribution. So A would follow the uniform distribution. So I can use the rand n method. So this would follow the normal distribution. It is similar to the rand method, and just that it follows the normal or the Gaussian distribution. So the numbers have negatives, which indicates that it is not from 0 to 1. It is following the Gaussian distribution. Here the Gaussian distribution would have the mean 0 and standard deviation of 1. So the values would range from -1 to 1 following the Gaussian distribution. Uh, the list of the different things you can do using the random package is provided in the documentation. So you should take a look at this documentation. Again, the link to the documentation would be provided in the resources file. So you can generate simple random data as we just did using the rand function or the random function, or you could pass an array to the shuffle or permutation method to shuffle the array. You could use any of these distribution to generate random functions. So you should take a look at this package as it is really important. Random functions are really important. So this brings us to the end of the lessons on NumPy. I hope you have had fun looking at NumPy, and you would continue playing with NumPy and build some really cool stuff using NumPy. So have fun.